Good day everyone, my name is Framalin Malo Villanueva from BSE 1E and today I'm going to discuss our next topic in Physics for Engineers, which is all about elastic collisions. So I have an example, a 1.60 kilogram block initially moving to the right with a velocity of 4 meters per second on a frictionless horizontal track collides with a massless spring attached to a second block with a mass of 2.10 kilograms moving to the left with a velocity of negative 2.50 kilograms. The spring has a spring constant of 600 Newton per meter. So, dalawa hinahanap dito sa example natin, which is the letter A question is to determine the velocity of the second block at the instant when the first block is moving to the right with a velocity of 3 meters per second. And the letter B question is to determine the compression of the spring at that time. So, para mahanap natin yung velocity of the second block, ang gagamitin nating formula or equation for this is the conservation of momentum. While to find naman sa compression of the spring at that time, ang gagamitin natin for this is yung conservation of energy. So, bago ko i-solve itong problem, ipapakita ko muna yung scenario. Kasi sabi dito sa problem, ito yung block 1 and ito yung block 2. Then, yung block 1 daw is meron siyang bigat na or mass na 1.60 kilograms. So, ito ngayon si mass 1. And then, si mass 2 naman, meron siyang bigat na 2.10 kilograms. Itong si mass 1 or si 1.60 kilogram is meron siyang speed na 4 meter per second patungo sa kanan. So, ayan. Habang ito namang si mass 2 is meron siyang speed na negative 2.50 meter per second going to the left naman. So, ang hinahanap is to determine the velocity of the second block. So, meaning, ang nawawala na dito is yung value ni velocity ng second block. Since given na yung value ni block 1 na velocity which is 3 meter per second. So, ito ngayon yung unknown. So, yung velocity ni block 2. So, yun yung isosolve or hahanapin natin ngayon. So, to find the velocity of the second block, ang formula nga natin dyan is yung conservation of momentum, which is P initial is equals to P final, which is also equals to mass 1 times V1 is equals to mass 2 times final velocity equals to M1 times V1 prime plus M2 times V2 prime. And since ang hinahanap si velocity, so kailangan si velocity lang yung matira. Kaya naman, V2 prime is equals to, magiging ganito na siya ngayon, mass 1 times V1 plus mass 2 times V2 minus mass 1 times V1 prime all over mass 2. So, since nakuha na natin yung equation to find the velocity, pwede na natin i-substitute yung given value. So, V2 prime is equals to mass 1 natin kanina, which is yung 1.60 kilograms, which is meron siyang velocity or initial velocity na 4 meter per seconds. I-plus natin yung mass 2, which is yung 2.10 kilograms na meron naman siya velocity na negative 2.5 meter per second minus yung mass 1 ulit na 1.60 kilograms times yun nga initial velocity prime na given kanina, which is 3 meter per second over mass 2 na 2.1 kilogram. So, ipagta-times lang natin lahat yan, then divide sa 2.1 kilograms. Makukuha na natin ngayon yung velocity of the second block, which is equivalent nga sa negative 1.738 meter per second. So, ito na ngayon yung value ni velocity or yung value ng velocity ng second block sa letter A question, given na yung velocity or yung initial velocity niya is to the right, which is 3 meter per second. So, yung final answer natin dito sa V2 prime natin or yung velocity ng second block is naging negative since yung velocity niya is going to the left na. Kaya negative na yung final answer natin. And to solve for letter B question naman, ang gagamitin nating formula doon is conservation of energy. So, isolve na din natin yun, which is letter B question is to find the compression spring at that time. So, for equation in conservation of energy is E initial is equals to E final. So, pwede siyang isulat sa 1/2 mass 1 V1 squared plus 1/2 mass 2 V2 squared plus Kx squared is also equal siya sa 1/2 mass 2 times V2 prime squared plus 1/2 times mass 2 ulit times V2 squared prime plus 1/2 ulit Kx squared final. So, ayan ngayon yung equation na gagamitin natin to get the compression of the spring at that time. Pero, eto kasi, bago pa sila mag-collide is hindi pa nako-compress yung spring, kaya si x is equals to 0. So, pwede na nating i-cancel. So, makakancel na si x. And, pwede na natin i-cancel tong mga 1/2 since cancelable naman sila. Yan. So, ang matitira na lang ngayon is 1/2 Kx final is equals to 1/2 times mass 1 times V1 squared plus 1/2 times mass 2 times V2 squared minus 1/2 times mass 2 V1 prime squared minus 1/2 mass 2 V2 squared. So, ayan, since ang hinahanap is compression of the spring at that time, i-divide lang natin to both sides sa K. Para matira yung X final. So, magiging ganito na siya ngayon. Cancel na to. X final. Since kinancel na natin tong 1/2, cancel na yan. Sorry na, isulat ko ulit. Pwede na natin i-cancel yung mga 1/2 na yan since cancelable naman na sila. And para natin mapadali yung or mapaikli yung equation natin. So, x final is equals to mass 1. Ito na ngayon yung matitira. Times v1 squared plus mass 2 times v2 squared minus mass 1 times v1 squared times v1 prime squared minus mass 2 times v2 prime squared. So, i-square root lang natin to both sides. Since kf squared to. Para mawala yung squared, i-square root lang natin both sides. Para ma-cancel. Ayan. So, matitira na ngayon yung x final. So, pwede na natin i-substitute yung given value. So, x final now is equals to mass 1 na 1.60 kilograms times v1 squared na 4 meter per seconds plus 2.2 kilograms or yung mass 2 natin na meron velocity na negative 2.5 meter per seconds minus 1.60 kilogram ulit or yung mass 1 times 3 meter per seconds minus 2.10 kilograms times negative 1.74 meter per second squared all over K natin is yung 600 Newton per meter squared. So, x final now is equals to 0.173 meter. So, ayan ngayon yung value ng compression of spring at that time, which is equivalent to 0.173 meters.